Hello everyone, welcome back to my channel. Today we will continuing with Java 8 features. In our second session, we will cover Lambda expressions. We will see in brief what are functional interfaces, and we'll also see how and where to use the Lambda expressions. So without any further delay, let's start. What is Lambda expression? So Lambda expression is an expression through which we can represent an anonymous function. Anonymous means that function is without any name. It helps in achieving functional programming in Java. It can be passed around as it was an object and executed on demand. The Lambda expressions are only applicable for functional interfaces single abstract method. So before deep dive into Lambda expression, let's first check what is a functional interface. So an interface which contains only single abstract method but can have multiple default and static methods is known as functional interface. For example, we already have many interfaces available in Java, like we have runnable, callable. So these interfaces are functional. Why? Because they have a single abstract method. Runnable is only having a single run method which is abstract, and callable is having only a call method which is abstract. Now let's create our own functional interface which we will be using in our demonstration. So let's name it as calculator interface. Let me just click on finish. So we have an annotation @ functional interface. So let's use this. I will tell you what is the use of this. Even if we do not use this, we can define a single abstract method here and it will work perfectly fine with Lambda expressions. But let's first just create this method. So we have int add, which can accept suppose two integers, int a and int b. So now this is our single abstract method. It will work fine. There is no compilation error. So as I have added functional interface here, it will not let me add any other abstract method in this. So suppose I want to try to add int multiply, int a, int b. So in this case, it will start giving me compilation error. So it is always better if we are trying to create functional interface to use functional interface annotation on top of the interface. So now our functional interface is ready. Now in our Lambda expression demo, we will try to demonstrate in both ways. First is using the traditional approach, how we were used to implement earlier the interfaces, and using the Lambda expressions also. So now let's first try it with the traditional approach. So if I want to implement the calculator interface in our main class, so let me just do that. Implements calculator interface. It will straight away give me a compilation error that I need to add the unimplemented method. So this is the old approach currently which I'm using. Okay, now let's do complete its implementation. It will return a plus b. That's it, right? And in our main method, we can directly use this implementation to find the sum. Now let's call this method. So for that we can create an object of directly this class also, but let's try to create the reference object of calculator interface cal and the object of Lambda expression demo. So here, sorry, I need to use new keyword also. So here I can use cal.add and I can provide the values here. So it is returning something. So let's put this inside system.out.println so that we'll be able to see the result. Okay, now let's execute the program. And here you can see sum 30 is printed. So it is working fine. Now we want to use Lambda expression for the same purpose. So for that, paste it here. So as we know, it's an anonymous method, anonymous function. So name, return type, and access modifiers are not required. Okay, so in this case, this becomes our parameter list and this becomes our body. But we have to use an arrow operator, which is also known as Lambda expression operator, just in between the parameters and the body. So this is how it has to be done, but still it is giving us some error. Why? Because it has to assign the whatever value it is returning, the method which we are creating here, it should be assigned to some reference variables. So for that, let me just create a calculator interfaces reference calculator. So with this, we are done with our first Lambda expression. So let me explain it here. So lambda expressions, as we have just discussed in our first slide, that they are only applicable for functional interfaces. So calculator interface is our functional interface. So whatever object or the references that we want to create for calculator interface, those can be directly assigned to the lambda expression. So here we have our lambda expression, which is expecting two parameters. After that, we have this arrow function and the body. The body is nothing but just returning a plus b, whatever parameters we are passing, it is adding them and returning it back. So now we are ready with our uh, functional interface and lambda expression. Now we try to use it. We have also discussed that it will act as an object here. So the cal itself, it contains the method for execution. So whenever we try to call cal, it can act as an object. So it will be cal dot add. You can see add function is coming in the suggestions. So cal is nothing but just acting as an object for this. We can do add 20 30. So if I try to run this, we are able to get the similar output here. Let's create another functional interface. I need to demonstrate to you like what all different type of parameters it can expect. It can be without parameter also. It can have a single parameter and two parameters also. So this is nothing but it will behave same as method. So method can have any number of parameters. Similarly, in the lambda expressions, we can also have any number of parameters. So let me create another interface greeter. So we need to define it as functional interface. In this, public void say hi. So it can let's add one parameter here, which is name. So whatever parameter I'm passing, we'll say hi to that specific name. This is our single abstract method. Let's go to our demonstration. And similarly, we just need to do the same thing here. Now we have greeter greet is equal to, now it only expect a single parameter. So for that, there is no need to add these parentheses or brackets. We can do it without that also, simply like obj, then this, and then body. Even if the body is of a single line, then also we can omit these parentheses as well. Okay, let me do in that way itself. One second. Sorry. So system.out.println. Now I'm saying hello to whatever value is being passed here. Okay, so that's it. This is how the lambda expression has been implemented. But if we see in the older way, if I implement the greeter interface, then I need to add the implementation of method separately, and then we will be able to call it. But here it is already done using the lambda expression under a single line. If I try to run it now, it will not print anything because it has just assigned the method body to this greet object. To get some sort of input output, we need to call it. So I have just executed and it has only printed 50, which was there from this system.out.println. So now let's try to use this greet dot say hi. So here you can see we are able to see say hi method available. So now whenever I'm doing greet dot say hi, it will go to this implementation and it will print hello and whatever value I'm passing to it. Let's execute it. So here you can see it has printed the complete value. Similar to this, we can have lambda expressions without any arguments also. So let's take an example of that as well. Let me create another interface, greeter2. Okay, so in this, let's declare it functional interface first, and after that, public void say hello, and I'm not expecting any parameter here. Okay, so we are done with this. Let's go to the implementation part. Greeter2 greet2 is equal to, so now we don't have any any arguments to pass, so it will be an empty brackets, and after that we have the arrow sign and then the body, and the body If we are having only single line, then we can provide it without the curly braces. But suppose we have multiple lines, so we need to give the parenthesis so that the block can be executed collectively. So let's try to print out two separate things. Hello there. How are you? Okay, so we have multiple statements here, just to give you an example of multiple statements and without any arguments. So we are done with the implementation of zero argument lambda expression also. So now let's try to use it. Greet2 dot say hello. So it will not expect anything. Let's try to execute it. So here you can see both the statements got executed. This is how we can implement the single abstract method using lambda expressions in a very neat and clean way. And also this type of programming paradigm is known as the functional programming. So here we are just assigning this whole function here itself in greet2, and we can use greet2 anywhere, and we can even pass it to the multiple methods as well if required. Now, as part of second demo for lambda expressions, let me create another class here. So here we will see what all scope objects or variables lambda expressions will be able to access. So we will see here local, instance variable, and static variables which can be accessed through lambda expressions. I will be accessing this local variable I inside my lambda expression here itself. So let me just create one more object here. So it is expecting me to add a return statement, just similar to the method. So if any method which is there, which is actually returning something, and we do not write any return statement in it, the similar error the compiler will start giving us until we add a return statement to that. Okay, so return is a plus b only. So that is actually the final result. I cannot write anything after return, so I need to access the variable I before that. First, it will print, it will call this method body to execute all the statements which are present in this. Then it will try to access the I, which is a local variable, and print its value with the local variable string as well. And in the end, it will return a plus b. So whatever value we are passing, it will return them, and that we have already added into sysO, so it will be printed to the console. So here you can see I am able to access the local variables, and the sum is also printed. So in similar way, if I have an instance variable or a static variable also, let me try to add a static variable. Okay, so now let's try to access static variable as well. So compiler has not given any error. Let's execute the program. So here you can see it is able to access the static variables also. So that means whatever data that we have available outside our lambda expression or the method body, that also we'll be able to access. But whatever is there inside, that will not be accessible outside. Whatever value we are returning, only that can be accessed. But any intermediate results which are available there, those will not be accessible outside the lambda expression. Now let's see one more example with which we will be using lambda expression to sort the custom objects. So suppose we have this student class which is having student ID, name, and country. I have added all the getter and setter methods, implemented the overridden the toString method as well, and added both the constructor, the argument, and no-arg constructor as well. I have created one static method which is just to populate the list of students. So without any sorting, first let's try to print the output. So here you can see without sorting, whatever order we have added, like we have added S1, John, Mike, and Andy in this order. So we'll be able to see in the same order. Now we want to do the sorting. So there are two ways. One will be the older way without using lambda expressions. Let's try to do it in that way first. So collections dot sort. So this specific utility class provides a sort method where we can pass the list and the comparator. So comparator is also one of the interfaces, which is a functional interface, and it provides a single method which we can use to compare the objects. You can see at the rate functional interfaces is add there. So that means it can only have a single abstract method. In the return, what we will be doing, o1 dot, so we'll be sorting it based on the student name, dot compare to o2 dot student name. So in this way, it will actually return the list in ascending order. Dot compare to method is already implemented for string class, but if it is not string, then we have to implement it separately. As it's already implemented in the string class, so we can directly use it. Print the complete list after sorting as well. So after sorting, we will be able to see Andy will come first, and then we will have John and then Mike. So here you can see first one is Andy, and then we have John, and then we have Mike. So if we want to reverse the order, we just need to reverse the comparison here. So we will do O2 here and O1 here. Then now we will see Mike, John, and Andy in that order. Now let's see. We can say Mike, John, and in the end we have Andy. So this was the older way of doing it. How this can be implemented using Lambda expression. Now let's just convert this specific implementation to Lambda expression as well. What do we need? We don't need this. And after that, we also don't need return because it's a single statement, and we just need this arrow. That's it. So now that whole method has been transformed to the Lambda expression using this. So now we are passing O1 and O2 two objects of the student type, and then in the method implementation method body we have O2 dot get student name dot compare to O1 dot get student name. So this will act same as the method that we have implemented earlier for sorting the student list in reverse order as per their names. So now let's just try to save it and execute the program. So here you can see we are able to see the similar result. Now let's just try to reverse the order again. Just replace O1 with O2 and execute it. So now again we can see the order has been reversed. So in this way you can see we are able to implement the whole method, that complex logic, in a single line using Lambda expressions. Let's see one more demonstration of usage of Lambda expression. So suppose we have this list of students. So if we want to iterate through this list of students, we can use a standard for loop with the index variable. We can use for each loop, and we have for each method which is available in the iterable interface. So that also we can use with the help of Lambda expression to print or iterate through all the student elements. Is student then dot for each. So it is expecting inside a consumer or action. So that can be defined as a Lambda expression. This exactly means that for one student at a time, what operation that we want to do. So suppose we want to just print the elements. So to print the elements, let's define our Lambda expression here. So here I will just print the s dot get student names. So in this way, using Lambda expression, we can provide the implementation for each as well. So let's just try to run this program. So here you can see we are able to print the first name of the all the students. So if I want to print anything else, like I want to print the country of those students, that also I can do, where you can see the countries are also printed. Now let's see one more and one of the last demonstration for today's video session. So we can use the Lambda expression with Stream API as well. We will discuss the Stream API in depth when its session will come. So let's just see how we can use the Lambda expression in our Stream API. So to do that, let's add the students object to Stream first, and then suppose we want to filter out something. So to filter out, there is a method filter. Inside that we can provide the Lambda expression. So in the filter, any student which is available, what we want to return, what we want to filter out, that s dot get country dot contains. So I just want to filter out all the students where country contains letter U. If as filter is an intermediate function, so it will not return anything, but it will filter out the results from student set. And once it has filtered out all the results where the country contains U, suppose we want to print that specific student. So for that we can again use the for each. For each we have already used previously. So let me just copy it from there itself. So we will use the for each, and instead of printing country, let's just print the whole student object here. Okay. So now in our line number 31, let me just explain what we are doing. We are using stream on students list, and after that we are filtering out the result based on what the criteria is written inside this specific Lambda expression, where country contains u. So wherever in for which student the country contains letter u, that will be filtered out of the students list. And in the end, for each, this is a terminal operation. So what it will do, it will take the input of all those filtered students from filter function and print that student detail. So here you can see it has printed two students only. Why these two students were printed? Because their country name contains U inside that. The third country was Canada. That's why it got filtered out in this specific operation. So this is how we will be using Lambda expressions to write clear and concise code, which is also much more readable and maintainable. So that's it for this video. If you like the video, please do like, share, and subscribe. Thanks for watching. See you next time.